Holy moly, it is 2:01 UTC on the 16th of February, 2015. Hey, everybody, glad you could come in. This is Cosmic, and you are watching a live stream called Astronomy Daily Live. And Uncle Bill is already in the house painting the place yellow, as he always does. Uh, yeah, Horizon Psi, I've watched a couple of his lectures too, and yeah, he at least his live stream is very serious, very right to the point, and good stuff. If you're still learning astronomical topics and sort of trying to get the idea of science and how scientists think and everything. Horizon Psi is absolutely fantastic. Huge shout out to Horizon Psi on Twitch TV. Speaking of shout outs, I haven't been doing a lot of shout outs lately, and I need to get back into the habit of doing that whilst I give everyone a few minutes to get in to this show. The one thing that, and maybe Uncle Bill, I can ask you to criticize this. Hey, there's Bob Dog too. Um, I've noticed that a lot of live streamers and podcasters, they to me, to me, they seem to talk really fast, and um, being that English is my first and only language, yeah, it's okay. But I mean, even sometimes it's like, wow, they're talking really fast. So I hope that I'm not speaking quite that fast. I don't think I am. I'm sort of a slow talker, I think, anyway. But but when I get excited about what I'm talking about, I can start talking fast. So yeah. Uh, okay. Well, hey, Bob Dog, it's kind of interesting that you mentioned the aurora, because that was actually one of the things that I was going to bring to the table today in my Discord channel, and you can find a link to that down in the description. Um, Earlier today, what's his name? Da, da, da. BillN.net, and that's his name, BillN.net, um, posted an article from Nature, which, if you go to nature.com right now, like right now, it's like the top story. I mean, literally at the top of the screen, at the top of the screen. Uh, it's an article entitled "Origins of Earth's Weird Pulsating Auroras Nailed Down." Okay, origins of Earth's weird pulsating auroras nailed down. So, Bob Dog, um, I would say, I would say, if there's an aurora going on in your vicinity, you need to be outside watching it. Don't do Please do not sit in here and watch this. Okay? No, there is no comparison, no comparison at all. But you probably know that. Um, but yeah, so I mean that's at least one of the things that I was going to bring to the conversation if nobody else had anything else. However, let me do some shout outs because I haven't done that and I really want to. Um, Most definitely to the weekly space hangout, Fraser Kane and uh, and guests. Usually have who Morgan in there, and what's the lady's name? I'm forgetting it now. Um, and sometimes they have Paul in there as well. Uh, Shoot, what's her name? I hate that. I'm terrible with names. But yeah, huge shout out to them. I'm still. They had a show today. Did they have a show today, or was it yesterday? Maybe it was yesterday. I still need to figure out exactly when they're coming on. They, I, I think because of recent travels and everything, maybe those were switched around. I don't know. I guess I don't pay that close enough attention to when things are happening. I'm just I just sort of wait as hopefully many of you do, and just wait for the notification, and then it's like, okay, can I watch this now or can't I? And if I can, I'm there. I'm definitely not ninja style. You know, for me, it's one at a time. One at a time. That's all I can handle. It's all this little mind can do. But yeah. So huge shout out to that show. They're always awesome. I've been watching them for years, and extremely awesome. Big shout out to Dennis Hands. He does a live stream on uh, man, I'm just on Periscope. On Periscope every Monday at 8 a.m. Eastern time, Eastern United States time. So that would be like 1 p.m. 1300 UTC on Mondays, and then he does a Wednesday Periscope live stream at 8 p.m. Eastern Time in the United States, which is 1 a.m., 1 hour UTC, I believe. Pretty sure that's right. Yeah. So uh, Dennis is awesome, and he's a teacher. He's been teaching for 40 years, and he is very good. And I love his sense of humor, and he knows his shit. And he puts up with a lot of of very strange comments. He usually just sort of ignores them, but he is reading every single one of them. And some of the people who come in there, I think they look like trolls, right? They're they're just in there to sort of get a rise out of him and cause some trouble. And his thing is to ignore them. Now I'm not quite sure how Periscope works, but um, if anything like that happens here on this channel, um, I am, as they say, I am the hammer. I am the hammer, and you will just go. So, we are talking astronomy here and science. We can get into lots of things. This is a very casual, um, fun, but um, hopefully educational live stream every single day, uh, focusing on um, uh, uh, astronomical topics. But yeah, we can go off on tangents and stuff. It's just like a circle of friends sitting around having one or two or three conversations at the same time, and conversations can sort of go everywhere. This hour ish or so, is dedicated to all the astronomical topics. So I don't want to get too far off, but anyway, Dennis Hands is great. Check him out. I think his Periscope uh, streams last for a while, so you can always go, to sort of his main Periscope page, and you'll be able to find at least several of his previous shows. I think he did. Yeah, he did a show last night that I caught this morning, and he was just fielding questions. I think he did. He I think he did mention at the beginning that he had some topics, but I don't think he ever got to them. So I'm going to start up my live stream over on my smartphone, if you don't mind, just momentarily. So big shout out to Dennis Hands. Big shout out to Tony Darnell with Deep Astronomy. This is a one-man band. Um, can't I can't compare myself to him yet, although I am a one-man band as well. But I, um, I I am more than happy to jump onto somebody else's train if it gets me to an interesting destination. So yeah, yeah, pretty much whatever it takes. I want to see growth. I definitely want to see growth. So, but that will come with time. I already know that the it's mostly just a little bit of luck, sort of the uh, certain people or certain number of people need to see a certain thing, and it just grows and grows and grows, and you know if this never gets incredibly huge, I don't care. I'm not necessarily interested in that. I would like a crowd though. I would like a crowd. So it would be very, very cool, especially since this is a daily show. I don't expect the same X number of people to come in every single day, right? Um, but maybe on a weekly shift, or every other day, or every other few days, pop in, say hi in the chat. If you're interested in being a panelist, send me an email, and request that, of course, and I'll put you down here along the bottom. I think it goes to be a panelist, and then we can have even a more live thing. And yeah, I think tomorrow is definitely the day that I'm going to work on the Discord audio. I just I've got to run it on this laptop. I can't be running it on my Linux machine for some reason that isn't behaving in that mode. And my guess is that it's going to work just fine on this laptop. So huge shout out to Tony. His live stream is every Thursday at 3 p.m. Eastern time, which is 8, which is 20 hours UTC. Um, and this week's show, I caught most of it live. It was all about TESS, and TESS is going to be the successor to Kepler. Um, the Kepler spacecraft is the thing that has found all these so-called extrasolar planets, thousands of them, thousands, and it's fabulous. It's fabulous. If they are planets, there's every indication that they are, but you know, as with a lot of things, it's you know, I'm just not into this sure thing, nail down stuff. So Here, let me go back over to let me look at the Discord first. Okay, nothing, nobody over in Discord, but there probably is a good chat going on, especially since Bob Dog is there. He always makes for good chat. So yeah, if Bob Dog, if the auroras are going as I said, you get outside. You get outside. See if you can see any of them pulsating like this. I'm gonna maybe get into a paper. They're talking about like a pulsation period of maybe like 5 seconds, something like that. So see if you can see any of them pulsing. Pulsing meaning just varying in brightness, just varying in brightness. So yeah, see if you can see any of that. I've uh, I've seen the aurora a few times. Uh-oh. Oh no, that's all right. The I've seen the aurora a few times. The three distinct times. Should I tell those stories? Okay. I'll tell my aurora stories. But first, but first, okay. Beverage chemical of choice tonight is all the way hydrogen hydroxide. Cheers. Now, I also do have coffee. Coffee here. This is the Kona blend. Now, a Kona blend is almost something that I'm not going to really want, because a previous job that I had brought me over to Maui several times a year for a few years, and let me tell you, that was absolute torture. Okay, you know, having to travel to Maui, getting set up in a condo on the beach. It was really it was pretty bad. It was pretty bad. Um, uh, and yeah, it was rough. Um, couldn't play the tourist much because I was there to work for a week. Hey, there's No Till Tom. Hey, nice to see you in here. Hope all the ladies are doing well for you. Um, cannot wait until the day that I can also participate in that. I've got a wife who really needs that, and I definitely want to be able to supply her with those things, and if possible, friends and myself as well. So we'll see. We'll see. I think uh, all the attitudes are going to change in terms of the politicians when the culture changes, because the politicians just follow the culture, and so regardless of what you hear or think or see. So when the culture changes, the politicians will change. Now the culture changes by individuals changing. So just work on yourself. That's all you've got to do, and change will happen. So anyway, glad to see you here. Where I was going with all of that is I was going to tell you some aurora stories. So the first aurora story, well, the first two happened uh, when I was young, probably yeah, maybe 10 or 11, 9, 10, 11, something like that. I was living at the time. where I grew up in eastern Washington State. So, we were at about a 45-degree latitude, 47, something like that. 45. I think the border with Canada isn't that like 49. So yeah, we were just you know just below the border of Canada. Now where I live now is just north of the Mexican border. So yeah, I'm definitely I guess I'm sort of a border person. Um, anyway, so the first two times, the first time was probably the well, maybe the second most extraordinary one that I'd ever seen, and this one was really really strange because it was like a just a sort of a grayish green blanket just just covered just moved over the sky and just covered the entire sky just this speed, just sort of like this, moving like this, okay, across the sky, and just filled the entire sky with this grayish green. It looked, I mean, if if it didn't look so strange, you would think that it was a cloud, okay, because of how it just sort of moved in and just covered the entire sky. And I don't remember how long that lasted. Don't remember that one. Another one that I saw as a kid, it was the spiky ones. So and these were definitely to our north. Um, Pretty high up though. I would say maybe 45 degrees or so high, but to the north, right? And the spiky ones are really really cool because they move so fast. I mean, it is literally and great colors, reds and greens, um, maybe some purples. I don't remember exactly if I saw the purples or not, but lots and lots and lots of color. So that was very, very cool. Now, the last time that I've ever seen the aurora was many, many years ago, actually, south of, yeah, south, even more south of where I am right now. Okay, I was on the southern slopes of Mount Hopkins, and Mount Hopkins houses um, um, a telescope called the MMT, which at the time stood for Multiple Mirror Telescope. This was a telescope that had six mirrors, six 1.8-meter mirrors, and it was an experiment to see what could be, could we make a large telescope, large aperture, um, with some smaller aperture mirrors, and answer, yes. Uh, did it work well? Um, as a light bucket, it worked awesome. As an interferometer, it was really, really tough. We did it. We did it. We used it as an interferometer. In fact, the first astronomical um, system that used any kind of adaptive optics was used at the MMT, and I was a part of that team that developed that. So that was extremely awesome, extremely fun. I will talk about adaptive optics during this live stream, and I'll get into um, some of the work I've done in the past and some of the work I am currently doing as well. Because one of the the purposes of this live stream is to find supporters for my work. I am set. Okay, I am set in terms of instrumentation. Okay, I have a good scope. I have a CCD camera that is a workhorse, awesome camera. It's beautiful. Uh, I have all the computing power I need. I'm a programmer, uh, and I'm also an astronomer. So I write all my own code. I do all my own analysis. Um, uh, yeah, so I am self-contained, and the only thing that I need to be able to do, my work full time is the ability to pay the bills. So, yeah, at some point, at some point, um, hopefully, supporters will uh, see this, see the value of sort of um, supporting research in a different way, as opposed to using tax dollars and all of that. It's more of a direct thing, right? And I think that's very powerful and very underrated. Um, but anyway, the probably the coolest um, display of the aurora that I've ever seen. I was on the southern slopes of Mount Hopkins. So when I looked north, okay, when I looked north, I saw. I mean, it was the mountain there, okay, and the mountain probably. I want to say that the top of the mountain was probably 25 or 30 degrees above the northern horizon. Okay, and I was there. I'm with a friend. He wanted to go to a dark site, and I thought, well, hey, I I know a dark site, so let's go. So we were there. He's a big, and I assume he still is. I haven't actually been in contact with him for quite a while. Um, Maybe through this live stream, we'll hook up again. That would be interesting. But anyway, he was really into um, uh, um, astrophotography, film, film. So at that time, this was the mid '90s or so. CCD cameras really weren't yet available, to like the amateur crowd or anything. CCDs was still, pretty limited uh, to the pros. Cheers. So we were there, and it was nice and dark. We had chosen a moonless night, and we got to the site, which was the gate. Okay, there's a gate, uh, a closed gate that has a combination uh, that if you can pass through, you can drive up to the observatory. So we were as high up on the mountain as we could go. Okay, so we were at the gate, and we set up our scopes. I don't remember. I don't remember if I brought mine or not. Don't remember if I brought mine. I have another telescope that I made when I was 13 years old, 12 or 13 or so. It's a Dobsonian. It's a 10-inch f5.6 reflector with a Newtonian focus. Built it myself. Did not make the mirror. Bought the mirror already made. But put all the pieces together, and that scope I have had ever since. I still have it. Um, changed the mount from a Dobsonian to a German equatorial a few years ago. Um, doesn't track, doesn't anything. It's a looking telescope. Okay, this is when you want to go out and just look at stuff. Perfect. absolutely perfect for looking. If you want to do any kind of science with it, you are SOL. There's absolutely no way. And if I get the hiccups tonight, I'm going to do something about it live. Yep, it is easy for me to get rid of the hiccups. So that is just not going to happen. And if it does, I will show you live the technique that I use to eliminate them almost almost like that. Yeah. All right, well, cool. So the Aurora story, we're at the base at we're at the gate of of the MMT. Okay. Of course, don't forget to bang the thumbs up. And just as a quick aside, my understanding is that with that accumulating thumbs up hits informs YouTube to suggest certain videos. And I think that's about as good as I can hope for, is to get a nice suggestion. So yeah, bang the thumbs up and follow me. Follow me. So we're at the gate at the MMT. We're as high up on the mountain as we can get. We've set up our scopes. Don't remember if I brought one or not, but we have some scopes out there. He's got his camera. He's taken photographs. This is film, right? This is film. So he's taking long exposures and short exposures and moving all over and everything else. And I turn around and look north, and I look up the mountain, and all of a sudden I start to see this red glow, and it's rising. It's rising, it's expanding, and it's getting brighter. Okay? So this red glow, this red glow is glowing and is expanding and is getting brighter. It's a brighter red. Okay? And I'm looking at this, okay, in real time. And the city of Tucson, Arizona is just to the north of Mount Hopkins by maybe 30 to 40 miles. Okay. So the first thing that pops into my head is, oh shit, something's happening in Tucson. Because, it was just this red glow that kept growing and growing and growing and growing. Right. And it's like, holy shit, this is it. This is, somebody pushed the wrong button or pushed a button and it's over. It's over, right? And so I'm standing there just going, oh no, oh no. And uh, my friend is watching this too, and he's pretty much saying the same thing. It's like, oh no, oh no. And all of a sudden, pretty much out of nowhere, we're both looking north. We start seeing these really sharp spikes, and they're just moving across the sky. Green and red, really, really sharp, not wide, really narrow, I should say, spikes. Maybe 10 um, 10 to 20 of them parallel, but all moving around, moving to the right, moving to the left. And when we saw that, we both thought exactly the same thing. It's like, oh my God, it's the aurora. It's the aurora from extreme southern Arizona. So yeah, at the time I wasn't paying much attention to those kinds of things, but there must have been some serious solar activity in order to cause the aurora to come so far south like that. So it was absolutely fantastic. Absolutely fantastic. So yeah. Bob Dog, I definitely, if you see the aurora, I would definitely like a report. Let us know what you saw. Maybe you can photograph it or videotape it. I don't know. Show it off. Show it off a little bit. You're down. Yeah, you're down in very very southern Alaska, but that is north enough. I mean, especially if you've got all the warnings and everything. Yeah, check it out. And if someone here hasn't ever seen the aurora, man, I encourage you to seek it out. You can go on to YouTube now and watch uh, recorded, but still, live. It's not sped up or anything. Real time. Northern Lights, um, and it's mind blowing. It's absolutely gorgeous. The motion and the colors and the lack of motion, how things seem to sort of just be um, stuck up there, while other things sort of move around. It's absolutely fabulous. So yeah, and definitely, if you get a chance to see it for your own eyes, to run out and watch these things happen, you will be blown away. You'll be blown away. It's absolutely fabulous, fabulous. So I don't think I got all the shout outs that I wanted to do. Da-da-da. We talked about Tony's show, deep uh, deep astronomy, deep astronomy. So he's on every Thursday, at 20 hours UTC. He says 3 p.m. Eastern time. I assume that means Eastern in the United States time. So definitely check all those out. They're very very awesome. I've been watching all of those for a very very long time. Very high quality. Very very awesome. Uh, Deep South, no auroras to see here. Yeah. That's all right. That's all right. You can watch them on YouTube. And Uncle Bill, if anybody is going to watch auroras, I know it's going to be you. All right. Well, cheers. Cheers. Yeah. Well, the one that I saw down here, this far south, must have been quite an extraordinary solar event. And I, it's easy enough to correlate those things, so I probably should at some point. But man, I'm just too casual, I guess, to worry about those kinds of things. I would much rather just sort of experience them and go wow. So, but yeah, if you know it's coming, that's probably even a little better. So yeah, yeah. Anyway, the Aurora stuff that I wanted to talk about, as I said, was pointed out on my on my Discord server on the astronomy channel. Was it the astronomy channel? Yeah, the astronomy channel. He had pointed out an article that has been published in Nature. Excuse me. And I'm going to share my screen so we can take a look at this together. There goes to infinity. We're going to come over here and we're going to come over here. So this is the Nature article that This is billn.net. Billn.net is one of our friends over on the Astronomy Daily Live Discord server. So everybody say hi to billn.net. Glad he's there. Very, very cool. So this is the article in Nature. I think what he pointed me to was an article at space.com, and I don't really stop the at sort of the media articles about things. I like to go straight to the source. I don't think I've never found that the media stories about astronomical things are uh, they're they're always not quite correct in some way. Either either how words are interpreted, or I think there's just a lot of a misunderstanding, and these reporters are put into a position where it's like they have to write something, right? So they do as good as they can, but it's never, at least in my opinion, right, it's never quite right. So I like to go to the source of the information, and in this case it was this Nature article, which, as I said, um, you go to nature.com right now. Okay, let's do it. Okay, let's go to nature.com, nature.com. You will see that the top article, the top thing right at the top, is shining a light on pulsating aurora. I mean, it's like right at the top. It's very cool, very timely, especially since Bob Dog is like out there looking at them right now. I think that's just totally, totally awesome. So, pulsating aurora from electron scattering by chorus waves. So there it is. Now the only problem with this article, it's a nice abstract, explains things relatively well. However, in order to get this article, you have to fork over some bucks. And oh, come on, people. Come on, really? Really? For what? For what? Come on. All of this work is paid for already. So, and oh, come on, it doesn't take anything to put it up on these. So, yeah, that's as far as we can get there, right? That's as far as we can get. Um, so they're talking about auroral pulsations with periods of several to tens of seconds. So that's kind of cool. They're talking about they're thinking that these pulsations are generated by the, quote, intermittent precipitation of energetic electrons. So several to tens of kilo electron volts. So that's pretty good. That's pretty good. Let's see, possible cause. Blah, blah, blah. Here we report that energetic electrons are scattered by chorus waves, resulting in their precipitation. Observations made on March 2017. So yeah, very, very cool stuff. Very, very cool. Um, I definitely do not know enough about the aurora to really be able to say a lot. The the idea, at least the story that is being told at the moment, is that, right, the Earth has this magnetic field caused by, well, yeah, maybe a rotating core. Um, yeah, hard to really know how that magnetic field is being created, but it's there. It's there, and I'm sure that there are some good theories, some good sound theories. But as I said, I'm not following that probably as closely as I should. So shame on me for not having the full story on these things. But as the story goes, Earth has this relatively strong magnetic field. Okay, and the sun is very, very active. It is always gushing out material. They call it CMEs, coronal mass ejections. Um, thought to be caused by these huge explosions, right? That just sort of blow things out uh, into into the um, into space, right? Out of the sun. And if it just so happens that these explosions shoot all of their stuff, which are like charged particles, protons, um, probably lots of charged material, right? Plasma, that kind of stuff. If it so happens that this material is ejected from the sun towards the Earth, then all that stuff is going to be caught up in the magnetic field of the Earth and sort of directed to the poles. And when these particles interact with the atmosphere of the Earth, with the air, right, it makes the air glow. And depending on what's in the air, I think what kind of particles they are, what kind of energies we're talking about, probably lots and lots of things that I don't know. Um, the the um, displays of the aurora can be extraordinary, right? So that's at least the story in terms of explaining uh, what is causing these things. I'm sort of thinking that the electrical effects are probably being overlooked a lot. Um, no one ever, in fact, the people who over I think over 100 years ago sort of guessed that the aurora, was some kind of an electrical thing or a magnetic thing, were laughed at, right? Because it's like, no, 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 it's something else, something else, something else. And it wasn't until spacecraft were flown into the aurora that it's like, oh, gee, oh, these are electrical, and this is plasma, and there is a magnetic part to all these things. So everybody talking now about being so sure about everything. It's like, no, probably not so sure. But anyway, as the story goes at the moment, that is sort of the explanation is that the material is being ejected by the sun, and this material is charged in some way. It has an electrical charge, and when something has an electrical charge, it can be affected by a magnetic field. And so when these charged particles being ejected by the sun uh, interact with the Earth's magnetic field or any of the planet's magnetic fields, that matter gets sort of directed to the poles, to the North Pole and the South Pole of, say, our planet Earth, and that motion is directed, towards the poles, into the poles, and when that stuff interacts with the air, it starts to glow. So very, very cool. Regardless, really, regardless of what's actually going on, isn't it cool just to sit back and watch all of that stuff go? I think it's fabulous. Yeah. Who needs to understand it if you can just, sit back and enjoy, right? Maybe we had some ugly solar events. Auroras are rare. Yeah. 41.5. Yeah, that's getting a little low. You got to have some pretty exciting activity to get that far down. But I would think at 41 and a half, yeah, you still be able to see it. You just have to be on the lookout for it, for for sure. Hey, Susan. Hope everything's okay with you. Everything is good here. Glad you could stop in for at least a little while. We're talking about auroras tonight. Bob Dog, who is a regular um, here, is somewhere in like the Juneau area. I think he's just north of Juneau, and he was saying at the beginning of of the live stream tonight that he had been warned that some auroras might be visible at his location. So I told him to get off of this stupid live stream, go outside and watch the aurora. So I hope he is doing that. I hope he's um, doing that. Anyway, another good friend, was it Bill N.net over on the Discord channel. Is that? Yes, BillN.net um, had posted this article that you're seeing up on the screen from Nature about the some of the auroras seem to pulsate. So they get bright and then dark and then bright and then dark and bright and then dark. And this article suggests a pulsation period of, they're saying like several to tens of seconds. So, and they think they have an explanation for why that's happening. But in order to get the answer, you have to fork over some some bucks, which is just absolutely ridiculous. Absolutely ridiculous. So I'm probably what I have done in the past and probably will do in the future, and even for this paper, is I will contact the primary author here. I'll send that person an email, and 99% of the time, when an author gets an email about a paper that they wrote, they are thrilled. They are thrilled that somebody is reading their paper because it takes a lot of work, to write all this stuff, collect all the data, reduce it, analyze it, argue about it, try to figure it out, try to understand it, and then you got to write the paper, you got to make all the drawings and all the plots and all the pictures and everything else. It's a lot of work. So when somebody says, hey, I read your paper, it's like, wow, wow, somebody's reading my paper. So I'll send this person, maybe a couple authors on here, a request for what's called a reprint. And I have always been successful in getting those things and not having to pay these people uh, anything for something that the authors are paying them to publish. I don't know if you folks know this, but in order to publish in Nature, you have to pay them. Okay, they don't pay the authors. Okay, you have to pay them. I don't know how much nature charges, and I don't know what the current rates are. But when I um, um, was publishing relatively heavy in the 90s, the Astrophysical Journal was $300 a page, $300 per page. So a 10-page paper, 3,000 bucks. So Nature charges their authors too, as far as I know. And so doubly so, it is ridiculous. It's ridiculous for anybody to have to pay to get any papers from Nature at all, especially online, because there is no effort there at all. None. They don't have to print anything. They don't have to do anything at all. They have to have a server, and that's it. They've got one anyway. Anyway, end of rant there. So what I did, since I didn't have access to this paper, I of course went over to archive.org and did a search for pulsating aurora, and well, I don't know why it's doing that. And I found this paper. And I'm going to go back over to the chat here just to make sure that nobody is misbehaving, especially Susan. You got to watch her, guys. Yeah, she'll mess you up. Yeah, you got to be nice. So I found this one, which I hopefully can zoom in on. I'm not going to bore you guys too much with a lot of this, but this one was interesting, and this one was published back in 2016. Okay, 2016 in the Journal of Geophysical Research section called Space Physics, right? The temporal characteristics and energy deposition of pulsating auroral patches. I just wanted to see some of these, right? And as you folks are probably learning, I love to look at pictures. I think if a book or an article doesn't have pictures, I just don't want to read it. So let's just go down to the pictures. Okay, you can read all this stuff on your own, and papers are always they all have sort of the same format, the same general format. The first part, maybe I'll go through this a little bit. The first part is, as it says, it's an introduction. So it's just sort of laying out, okay, this is what we've observed. This is, this is sort of the history. As you can see, there are references here. And these references are a history lesson about sort of, the topic that is being discussed in the previous sentence, right? So it's really, really cool, just to jump references, because you learn not only a lot about the subject itself, but you get sort of a history lesson. This is really, really cool, right? This paper was written in 2016, and he's referencing a paper from 1977. And if you go to this paper, you will see references to past papers. And if you go to those papers, it just goes back and back and back and back and back. It's really, really cool. If you're into, the history um, um, of astronomy, just really, really, really just go to a random paper and go to a random reference and just go from there. It's really cool. You'll learn a lot. So these introductions, just sort of lay out uh, the observations that have been made in the past, some of the guesses, some of the history of what's going on, blah, 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 blah. Okay. Then they get into, okay, so now we have a theory. Let's go and collect some data. So that's what this second section is about. And ooh, we're getting into plots and stuff. Let me back this out a little bit so we can maybe see the whole plot. So what I like to do is I just like to go through these things. I'll read the little thing down here, the little comments about stuff, and maybe you'll understand it, or maybe I won't. Not really important. Uh, yes, the auroras are beautiful, but the effects of solar events on my beloved tech and fave astronauts is not beautiful. Yeah. Space is a very hazardous place for us, but we're going to figure that out. We're Yeah, we'll definitely figure that out. Uncle Bill, you are awesome. You are awesome. So here's some plots. Don't really know what it is. The bottom is obviously a time in UT time. See, real scientists only think in UT, just like real scientists always have a calculator at arm's reach. So they're just they're talking about their data, and they're talking about how they are collecting their data. Oh, here's some pictures. Okay, so they're um, they're using an all sky camera, which means it has like a fisheye lens, so you can see the entire sky at the same time. And then they are looking at one wavelength. Right? I should have pointed that out up here. I think it's up in the abstract. So they were using an all sky camera, looking in the green. So 557.7 nanometers is the wavelength. And they were doing that 3 times a second. So 3.3 hertz. 3.3 times a second. Yeah. What is 3.3 times a second? How long of an exposure time is that? 3.3, 1 over that. Well, it's about a third of a second or so. Yeah. All right. So let's get into more of the pictures here. So this first one is just they took the all sky image and they flattened it out, right? They stretched the edges, they just made it flat, right? So, and according to this patch of the sky is 4 square kilometers. That's cool. Kilometers by 2 kilometers. Patch identification, correcting for Earth's rotation. I was looking at this thing before, and I don't know what a kilogram is. So, yeah, we're going to have to pass on that one. I just don't know what a kilogram is. Here's some more. Patch number 2 of the first 3. Yeah, okay. Yeah, they talk about on time and off time. So there's a little patch that they have identified there. Okay, so each pixel is 4 kilometers square. I guess that's how I would read this, because this is in kilometers too, and we're talking about what, like 100, almost 160 by 160. So yeah, each each pixel must be 2 kilometers on a side. So there's just intensity, so the brightness of of a patch versus time. And yeah, you're seeing it getting brighter and darker, brighter, and then dark, and then bright again really fast, and then dark again, and then bright again. So Here they're just defining their terms, right? Here's the on time, here's the off time, blah 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 blah. And so you can measure the duration of your off time and your on time. Very cool stuff. So here's some, looks like some actual intensity data taken over just a few minutes. See that? This is going from like 1521 UTC, maybe 1520, maybe to 1525, something like that. So just a few minutes here of time. And they're looking at these patches, and it's like, yeah, it's getting brighter and fainter and brighter and fainter, brighter and fainter. Doesn't seem to have any period to it though. That's kind of hard to see a periodicity there. Maybe in here, right? There's this bright, sort of looks like it blinked a few times. Very cool. Oh, here's some actual real pictures. So, of course, this is just a portion, right? But here it's faint, here it's bright, here it's faint, here it's bright. Cool. So then they've got uh, little arrows or little lines indicating where these occurred. So this image here was taken right here. This image was taken when it was really bright. You see, it's bright here. This patch is bright. Makes sense. This patch is now dark, right? It's way, way, way down here. And yep, it's dark. There's another bright patch. This is very cool stuff. And it's fast, pretty fast. That's kind of neat. Then they get into the analysis, right? Statistics. They look at the temporal characteristics. Oh, more plots, more pictures. It's awesome. I could swim in this for a long, long, long time. So this they've done an analysis of the um, you know uh, the the durations of the on time uh, flashes, and as you can see, yeah, they're getting a period of at least a peak period. Whoops, of what, about 4.5 seconds, something like that. Yeah, that's cool. So here's some more. Okay, duration. So time and number of pulses for each of the patches. So they looked at six different patches apparently for different periods of time, and they counted the number of pulses that they saw. And yeah, there's an interesting correlation there, of course, between how long they looked and how many pulses they saw. But I don't know if that's telling us anything or not. Oh, they're measuring how much energy is dissipated. Look at these cool colored plots, man. Awesome. I swear, there's art in a lot of these papers. Great stuff. Yeah, Susan, if you want to join the Discord or anything else, I've got some links down in the description. Feel free to join up there. The Discord is also sort of a chat, but it's sort of a permanent chat, and you can go in there anytime and have conversations or post things. I've been posting um, things that I find, um, and others have been doing exactly the same thing. So I'm not going to belabor this too long because oh wow, I'm already over an hour. It's amazing. Time flies when you're having fun, and I'm telling you guys, this live stream hour seems to last about 3 minutes. So I must be having a lot of fun. So yeah, this needs a little bit more investigation. There's more and more plots. So once they show, they've collected this data, they've analyzed the data, now they're going to discuss the results and how they are interpreting their results. And so they'll go through all this. Oh, here's a sideways table that you can't see. Let's see. I want to see what this is, what this says at least. It says the most frequently mentioned theories of pulsating aurora, their auroral observational consequences, and how they fit within the observational constraints of pulsating auroral patches. So they've got a number of them here. 1, 2, 3, 4, 5 of them. Nonlinear relaxation oscillator. And there's a reference. Nonlinear pulsation model. Flow cyclotron maser. Okay. Backward wave oscillator and ULF waves. Cool. Oh, and there's more. Oh my gosh, there's even more. Fermi type acceleration, ionospheric ion acoustic instability. See, when I say these kinds of things, I sound really, really smart. I have no idea what that is. Auroral acceleration region modulation by Alphen waves. That's interesting because Hans Alphen recognized, the electrical nature of the universe, and I have also, and yeah, interesting, cool stuff. Nice summary. Nice summary. Let's see if there's any more pictures. This is just a lot of yammering here. Probably a lot of good stuff too. I'm definitely going to read this because it's a subject, as I said at the beginning, that I do not know a lot about, and I'm thinking that a paper like this is really going to teach me a lot about the aurora and what it's doing, at least what is thought it's doing. Lots of references. I like having a lot of references. All right, well, cool. I think that Bob Dog has gone outside to look at the aurora because I have not seen him in here for quite a while. So I hope that he is watching the auroras. He's up in southeastern Alaska, I think just north of Juneau. So yeah, he's got a great opportunity. Uh, well, he lives in a great place, to be able to see those kinds of things. But you know what? I think it's about time to exit this planet. I've got to get back up to the ship. It's just they only let me out for a certain amount of time. There's a little bit of leeway, little bit, but not much. They usually start tapping, their shoes about this time, and it's like, all right, where is he? Where is he? We only let him out for a little while here, so yeah, I got to get back up to the ship. One more, one more uh, gulp of this really amazing chemical, hydrogen hydroxide. Look it up. It's probably the most amazing molecule in the universe. And yeah, there it is. Cheers. Now, Susan, tonight it's HOH, hydrogen hydroxide. Sometimes on, yeah, a couple times a week, I can handle dihydrogen oxide, but mm, it's uh, it when I want to relax, it's hydrogen hydroxide all the way. So, all right, I'm gonna get out of here because yeah, they're waiting. We got places to go, things to see, and auroras to create. So yeah, I better get out of here. I definitely respect your time as well. Thanks for coming in. Hey, I will be back here tomorrow, 2 hours UTC. I'm here every single day. If you're coming in for the first time, hit the subscribe down there, hit the like. You can turn on notifications so you don't even have to figure out when this live stream is on at your location. Now, if you want to, figure it out, right? It's sort of a gateway um, into the astronomical world. Once you start getting a grasp of time and how it's measured, um, you're on your way, to be doing some cool astronomy stuff. So yeah. So I think for now, I am going to exit, get get off of this rock for a while, and but yeah, I'll land again here in less than 23 hours from now. From now. So all right, thanks, friends. I will see you tomorrow night. Okay, take care. Peace.